Okay, for these two problems, we're going to actually work backwards from what we were doing before. And now we're going to be given the symbol and the mass number A, and we're going to have to use this to figure out number of protons, neutrons, and electrons in the actual atom as written. So in the first one, we can see it's 97 technetium. So the first thing we need to do is sort of get a little more information here. So we know that it's 97 over, we need to look on the periodic table. You look it up, it's number 43, so that's our Z, so we're really dealing with that. And we know that it's got a charge of 0, it's neutral, so we're not really going to have to worry about the charge at all there. Alright, so looking at this, we know therefore that our protons is equal to Z, so our protons are equal to 43. We know that the neutrons is going to be the difference between the protons and the mass number, so 97 minus 43. Okay, and that's going to be equal to 54. And lastly comes the electrons. Okay, in this case, because it's a neutral atom, the number of electrons, the minus charges have to balance out the positive charges from the protons. We have 43 of those, so we must have 43 electrons. So if we take a look at it here, protons 43, our neutrons are 54, and our electrons 43. Okay, let's take a look at the second one. Okay, for this one we are looking at nickel, 63 nickel 2+. And the first thing we need to do again is look on the table. You can see it's a transition metal. It has a Z atomic number of 28. That means that the protons are 28, right? Because that's equal to the atomic number on the table. Okay, again, finding the neutrons now. We need to do the mass number, 63. And we need to take away the number of protons, which is 28. Okay, and so what we're going to end up with is 35 neutrons. And then the last thing we need to do is the electrons. Now here's a case where we have a charge. So we have to deal with this a little differently than we've been dealing with it up to this point. And the way we need to do is take a look at the net of 2+, right? We've got an ion here. So we know that we have 28+ as our charge, and therefore we know if it's going to end up as 2+ net, it's got to be 26 minus, because that would give us 2+ net charge. We have 2 fewer electrons than we do protons. So that means for the electrons, okay, that's simply going to be equal to 26. Alright, so there you go, 26 electrons. 35 for the neutrons, and 28 for the protons.